Today we're going to talk about calculating average atomic mass, and we're going to be using information that you would have learned in the last section where you did the ChemThink simulation, and that was looking at the mass number. So we're actually going to look at two different types of average atomic mass calculations. So the first one we're going to do is using mass number. And so here's my element that I've chosen. Okay, so this is the element neon, and there are three different atoms represented here of neon, and these are called isotopes. And the term isotope means that we have atoms of the same element, but they have a different number of neutrons, which is going to give them a different mass. And isotopes of an element are naturally occurring. So there are three isotopes here of neon. There's neon 20, which means that it has 10 protons and 10 neutrons. There's neon 21, which has 10 protons and 11 neutrons. And there's neon 22, which has 10 protons and 12 neutrons. And so here's how abundant they are in the world. So neon 20 is found 90.5% of the time. Neon 21 is found less than 1% of the time. And neon 22 is found less than 10% of the time. So we're going to use their mass number and their percent abundance to calculate average atomic mass. Okay. And so to calculate average atomic mass, we are going to take the percent abundance and we're going to multiply it by the mass of each isotope. And then we're going to take those products and we're going to add the products for each isotope and add them together. Okay, so we're going to do our neon problem here. And so we're going to do neon 20. Now, when we take the percentage, we want to convert it to a decimal. So you're going to divide by 100. So we're going to have 0.9048. And we're going to multiply that by the mass of 20. And we're going to get a product here. We're going to do the same thing for neon 21. We're going to take the percent abundance and divide by 100. And then we're going to multiply it by its mass number. So we've seen this notation before. We know this is hyphen notation. And we're going to do the same thing for neon 21, or 22, I'm sorry. Okay. So we're going to take 9.25%, divide by 100, and then multiply by the mass number. Okay. So if you want to pause our video here and get out your calculator, So we're going to solve for neon 20 first. So 0.9048 multiplied by 20. Okay. Now to get that 20, there would actually just be that's a counting number. We know from chapter 2, counting numbers have infinitely many significant figures, so we don't use those for rounding. So we're going to use that percentage for rounding. So there's 4 significant figures in our percentage. So I'm going to round this to 18.10. Okay, we're going to do that same thing with neon 21. Okay, and our percentage here only has 2 significant figures. So when I round, I get 0.057. And neon 22, the percentage has 3 significant figures. So this is going to have 3 significant figures. All right, so we've done step number 1 here. We'd multiply these together. Now we're going to sum them together. So we're going to add those 3 products together. All right, now remember that here we're looking at decimal places when we add. So both neon 22 and neon 21 have 3, but neon 20 only has 2, which would be the least number of sig figs, or least number of decimal places. So I'm going to get 18.34 here. And atomic mass typically has units of AMUs. Okay, so that's my first one that we're going to do. And here, all I was given was the percentages and the mass numbers. Let's look at a second example. Okay. And in my second example, we're going to use copper. And so copper actually has 2 isotopes. It has copper 63 and it has copper 65. And so copper 63 is 69.15% abundant, and copper 65 is 30.85% abundant. But this time, instead of giving you the mass number, I want to give the actual mass values. So the actual mass value for copper 63 is this value. Okay, so 62.929601 ATM, which is atomic mass units. Okay, and the symbol for atomic mass units is actually this lowercase u. Okay. Right. And then copper 65 has an actual mass of this. So 64.927794 atomic mass units. Okay, so we're going to do exactly what we did before. For each isotope, we're going to take the percentage and multiply it by, in this case, the atomic mass of the isotope and not the mass number. Okay. Now remember, we're going to convert that percentage to a decimal. So we're going to need to divide 69.15 by 100, and we get 69 or 0.6915, and we're going to multiply that by the mass. All right, 65. So we're going to take the percentage and divide by 100. So we're going to get 0.3085, and we're going to multiply it by its mass. All right, now I I'm not going to round until the end of all my calculations. So I'm going to multiply the percentage times the mass, and whatever my calculator displays, I'm going to write down the entire value. And then we'll go back and talk sig figs. And I'm going to do the same thing with copper 65. All right, so now that I have my products, we're going to add these together, but let's look at sig figs. So obviously there are lots of significant figures in the atomic mass. So the fewest one is the one that's in the percentage. So if I look at the percentages, both of these percentages have 4 sig figs. Okay. So I underline the digits that are significant. So that way when I go back, I can see that my answer should have 2 decimal places. Okay, because remember that when we're adding together numbers, we go with the fewest decimal places. Okay, so let me add these together. And when I do, I'm going to get this value when I round. And then this is my unit of AMUs. Okay, so you should be able to calculate average atomic mass no matter if I give you the mass number or if I've given you the actual masses of the isotopes. Also, you should now know the definition of an isotope. And we're going to use that isotopes when we get to nuclear chemistry. That'll be our next topic. Okay. And we'll actually use those average atomic mass values when we get to our mole topic in this section also.